Hello, in this video we're going to talk about how to implement the bubble sort that we talked about in the last video. So remember the big idea of a bubble sort from the last video, right? We are just repeatedly bubbling or moving the largest one to the end and then the second largest one to the one before the largest one and so on, right? So we're going to loop through this many times, right? So let's just write one function that would do one round of work first. And we can name that flow largest to the top. Um, okay, so let me actually pull this up. This is flow largest to the top. So remember what we actually how we can actually flow the largest to the top is we do comparison of a pair of elements in the array, right? Pair by pair by pair, and then we move it down one pair at a time. And if the pair is not in the right order, we swap them. So basically, we have to do it in the loop, right? Because we're going down the entire list. So I'm going to say for I is going to be the index into the list. So in for I in, now here's the question. Think about this. How many times do we actually loop? How many comparisons are we going to have to do? So think about that for a moment. Now, what it actually is, if you remember, in our example where I think there are 5 elements in the list, how many comparisons do we actually do? Well, we do 4 comparisons because there are 4 pairs, right? So we don't exactly go to do the number of elements, but basically the number of elements minus 1. Okay, so if you kind of forget it, go back to the previous one and go look at the list and figure out how many pairs we actually have to compare. It's the number of elements minus 1. Okay, so that's the first important part. Okay, the second thing is, okay, for each pair we have to check if we have to swap, right? So what is the condition that we have to swap? So obviously, if in the list the ith element is bigger than the one next to it, which it will be I minus I plus 1, right? In that case, if the first in the pair is bigger than the second in the pair, then we want to swap them because we want the ones in front to be smaller, right? We're also sorting it in the ascending order, remember. So when this happens, we want to swap them. Okay, how do we swap them? Can we just do this I plus 1? Now that would assign the one on the right to the one on the left. Then do we just do the other way around? Well, actually, why don't we give this a try? We should test our code as we do as we write it, right? So if I just do this float to the LST, actually, I mean, before I do this, think about this for a moment. Does that actually work? All right, I'm gonna run it, and so I'm gonna do this. Oops. Sorry. Apparently, it doesn't return anything, so it won't work. So, but it will sort it in place. Apologies. Should practice more. Okay. All right. So, what happened? Why are we repeating 18 and 18 and 5 and 5? And what happened to our 99 and whatever 30? Well, if you think about this a little more, this does not really swap things, right? When we come to this pair, okay, this pair we are out of order, so we want to swap it. We assign the one on the right to the one on to the left. So we assign 18 to 99. So now we actually have 18 and we have 18. Okay, and then if we do the next thing, if we assign it back, then we're just assigning 18 into 18. So we killed 99 and we are left with two 18s. That's not the right way to swap things. Okay, so what is the right way to swap things? One is obviously, since we can't just put A into B and then B back into A, we can use a temporary variable. So the idea is, maybe we can, since we're going to override whatever is there at I, we'll save I first, right? Then we put the I plus 1 into I, and then I plus 1 gets whatever was in I before, and we save it in, which we saved in temp. So that's how we can swap things using a third temporary variable. If you see that, now this time we actually are able to bubble 99 all the way to the end, and we didn't lose anybody. Okay, so if you want to see how it works pictorially, it's the first step when we save the item at I into temp. And then the second step is we move whatever's in I plus 1 into I. And the third step, we take what's in temp and into the I plus 1 position. Okay, so this is typically what you would do in languages like C and C++. Being Python, there's actually a better way to do it, and I'll show you how. So basically, remember the idea was we want to swap them, but we cannot do this because this happens sequentially, right? Once we do this assignment, we lose what's in I. The Python way to do this is to do these two things, quote unquote, simultaneously. And you can do that by doing a tuple assignment. So what you can actually do is, I'm going to do these two at the same time. So I'm going to assign list of I and list of I plus 1. List of I gets list of I plus 1. And then list of I plus 1 gets list I. Okay, so this does what we want to do, but the reason that this works and what we wrote previously didn't work is these two things happen simultaneously. So let's run it to prove that it actually works. There. So it works if you write it this way. And again, this is this is kind of a Pythonic way of swapping things, and we don't need a third temporary variable for this. So this is what this slide is trying to show here. All right, so now we're done. We're done with doing one round of work, and this obviously is already floating the largest to the very top. Okay, so that's good. And now then we have to use this, right? So to sort, remember we just repeatedly have to float the largest and then the second largest, so on and so forth, to the top, right? So we just have to do this a number of times. So the question is then, how many times do we have to do? So think about it for a moment. How many times do we have to call this in order to sort everything? Oh, remember, if you kind of remember what we actually did previously, is that for our list of 5 integers, we needed 4 rounds. Okay, and then if you think about it, if your list only have 1 integer, how many rounds do you need? Well, 1 integer, it's kind of already sorted. So if the list only have 1 integer, you don't need to go through any of these rounds at all. So hopefully you kind of see the pattern here, is that for a list with n elements, we need n minus 1 rounds. So to implement that in code, we can simply write, define, I'm going to call it bubble sort list, and I'm going to do this. I don't really need an I, so I'm just going to use the underscore in range from the length of the list minus 1. Okay, and I simply just call float largest to the top and the list. I do this number of elements minus 1 times. That's it. Now, before I run this, I just want to point out one thing we already talked about last time, is if you just do 1 round of float largest to the top, is the list sorted? Well, it's not, right? We only floated one number, one of the largest one to the top. So we haven't really sorted. That's why we have to do this repeatedly. Okay, so now let's actually, instead of just doing it one time, we're going to sort the whole thing. Okay, let's hope that works. And there. So we have 5, 7, 18, 30, and 99. It works. Okay, so that's how it's done. And yeah, it's just call it enough times to sort everything. So I think I'm actually going to record a separate video to do the optimization and the rest of the exercise. So that's the end of this video.